What we're going to do today are sum and difference identities, okay? But we're going to be drawing pictures. Always draw diagrams in the correct quadrants, of course. So it tells us that sine of alpha is 4 over 5. And I know that sine is opposite over hypotenuse. Okay, now here's our clue. The alpha angle is between pi over 2 and pi. So let's try to figure out where pi over 2 and pi is. That's right here, so I'm going to draw mine in quadrant 2. Now let's make sure we do this the right way. Put your pencil on the origin. Go into the quadrant and directly to the x-axis. And this angle right here is called alpha. Make sure you put alpha for the alpha picture because we're going to draw a beta picture in just a moment. Okay, if that's the alpha angle, opposite would be 4 and hypotenuse would be 5. And now to figure out the other side, what you're going to have to do is a little SOHCAHTOA action. SOHCAHTOA. So let's go ahead and do this. Or maybe you guys might know that this is a 3, 4, 5 triangle. So let me just get out my red pen. And I'm going to label this leg right here with the number. Wait, did you say the right number? Did you say -3? Okay, because it goes left. So you have to make sure if you go left or down, you put your negatives. All right, now let's go over here and draw the next picture. Let's draw a picture for beta. Beta is in which quadrant, class? That's right. Pi and 3 pi over 2 is right here, so draw your picture in quadrant 3. That's how you draw a right triangle. This is the beta picture, so make sure you put a beta there. Sine is opposite over hypotenuse. Opposite is 2, hypotenuse radical 5. Who is going to get the negative? Can both of them get it? No, because that would cancel out. The hypotenuse never gets it. The 2 needs to go here on the leg going down, of course. And now we're going to do a little Pythagorean theorem problem. I'll call this side a squared plus the other leg. Yeah, use parentheses, quantity squared equals c squared. So let's do some calculations. A negative squared is going to make a positive. This is going to make a 5. A squared is 1. When you square root 1, you get a 1. So the length of this leg is how much? Wait, did you guys remember to say -1 again? Okay. All right, now that you've got your diagrams drawn, we have everything we need to do some problems. First, let's just see if you can do a cosine problem. So look at the alpha picture. Looking at the alpha picture, cosine is adjacent over hypotenuse. Okay, just a little warm-up. Well, let's do a beta problem. Go to the beta picture and tell me cosine, which is adjacent, -1, over radical 5. Can anybody rationalize that for me? Great, thanks. Okay, so now we've got some basics. Now, how do you do cosine of alpha plus beta? Well, thankfully we have a song to help us with such things. Can you guys sing the cosine song for me? Thanks. Cosine, cosine, sine, sine. Wait, should I put a plus or a minus here? Oh yeah, the whole switcheroo. So we'll put a minus. Cosine alpha, cosine beta, minus sine alpha, sine beta. So now all I have to figure out is what all of these things are, and I'll be able to do the problem. Cosine of alpha, you can look at the alpha picture or just look right there because we've already calculated that. So we have -3/5. Cosine for beta, do you want to use the 1 over radical 5 or the one that's been rationalized? I think the rationalized one's going to make easier denominators over here. Sine of alpha. Let's go to alpha and do opposite over hypotenuse and get 4 over 5. Sine of beta. -2 over radical 5. Can anybody rationalize that for me? -2 radical 5 over 5. All right, look at that. Look at that. We've got a denominator of 25 here and a denominator of 25 there. Built-in common denominators. I love it. A negative times a negative makes a positive 3 radical 5. A positive times a negative is going to make a negative 8 radical 5, but these negatives are going to cancel. And the question is, can I put those together? Do radical 5s get added to radical 5s? Yes, since they are like, which is going to make us 11 radical 5 over 25. Can I cancel by 5? No, not legal. A radical would cancel with a radical, a plain number with a plain number, a letter with the same letter. So this is the answer. Alright, let's try it again. Oh wait, we have to sing a sine song first. How does that sine song go? Sine, cosine, cosine, sine. Sometimes I just sing the song and then I put the letters in next. The letters are alpha, beta. So it goes alpha, beta, alpha, beta. And then I have to put something here. Should it be plus or minus? Yeah, it's going to be a plus. Alright, let's go ahead and get our parentheses all set up. Parenthesis, 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 parenthesis. Now we just have to figure out what the fractions are. What's sine of alpha? 4 over 5. Look at the beta picture and tell me cosine of beta. Oh, good. Negative 5, radical 5 over 5, rationalized. Cosine of alpha. Negative 3 over 5. Sine of beta. Yeah, let's rationalize and say negative 2 radical 5 over 5. So the first fraction, you multiply denominator with denominator, and you multiply numerators. That's how you multiply fractions. This isn't common denominator work because you're multiplying. Negative 4 radical 5. Plus over here, 5 times 5 makes a denominator, and the numerator is positive 6 radical 5. Can radical 5s get added to radical 5s? Yes, those are like radicals. So the numerator is 2 radical 5 over common denominator of 25. So when you're adding fractions, you keep the common denominator. Okay, so it's just like yesterday's songs, except instead of unit circle, we're going to have to draw our own triangle. Let's try it again. Okay, always draw diagrams. Okay, I will. I'm going to draw an alpha picture, and I will draw a beta picture. First, we have to figure out which quadrant alpha is going to be drawn in. So let's look at this hint right here and figure out which quadrant he goes in. Quadrant 1. Quadrant 1. Okay, that's how you draw. Don't forget to put alpha for the alpha picture. Label your diagram. Sine is opposite over hypotenuse. So the opposite is radical 3. Hypotenuse is 3. Okay, why don't you pause the video and everybody do a Pythagorean theorem to see if you can find that side. Okay, welcome back. Did you get radical 6? Okay, good job. Now let's take a look at the beta picture. Beta has to, negative pi over 2. Negative pi over 2 would be swinging down to here, and beta is between 0. So between here and here puts me in quadrant 4. Quadrant 4 is the clue for that one. So let's draw the triangle with the beta. Cosine is adjacent over hypotenuse. The adjacent is 2 radical 5, hypotenuse 5. Let's do a little Pythagorean theorem problem. So I'll say a squared plus, let's use parentheses, the b squared equals 5 squared. Alright, let's see, who's going to get squared here, the 2 or the radical 5? Yes, both of them. So what's 4 times 5? 20 equals 25. A squared is a 5, so A is radical 5. So let's go ahead and label that leg right there. How long is this leg? Did you shout out negative radical 5? Okay, don't forget, if it goes down or left, you have to put the negative on. Alright, we have to find cosine of alpha minus beta. So I guess we're going to have to sing a cosine song. How does cosine go? Cosine, cosine, sine, sine. So let's get our song written down. I've got alpha, then beta. So alpha, then beta, then alpha, then beta. Plus or minus, class? Ooh, switcheroo, we'll do the plus. Alright, let's get our parentheses all set up here. Alrighty, cosine of alpha. So let's look at the alpha picture. Cosine is adjacent over hypotenuse, radical 6 over 3. Cosine of the beta, adjacent over hypotenuse, 2 radical 5 over 5. Okay, back to the alpha picture for sine. Opposite over hypotenuse, radical 3 over 3. Back to the beta picture. Sine is opposite over hypotenuse, negative radical 5 over 5. So the first two fractions get multiplied together. Denominator is 15. Number times number makes 2. Radical times radical makes a 30. Can that get simplified? I know it's 6 times 5, but can anybody come out? No, so that's in simplified form. Yes, you have to simplify the radicals if you can. Here, I'm going to say minus radical 15. Oh, and the common denominator is 15, so we'll go like that. Can those radicals get combined? No, they're not like radicals. Only radical 15s can get combined with radical 15s. Okay, let's go do a tangent problem. Now, there's no song, I don't think. I haven't heard one yet, but maybe you have one for tangent. So I know he's got that big fraction bar, and it goes tangent alpha plus tangent of beta. And the denominator is going to be 1 minus tangent tangent. So tangent of alpha times tangent of beta. Alright, let's go ahead and get a big fraction bar and get a lot of parentheses all set up. I got to put an answer there and an answer there. Well, once I have those figured out, I can just put them again in the bottom. But we'll have to use the pictures carefully. So let's go look at the alpha picture to figure out tangent. Tangent is opposite over adjacent. So I guess I could say tangent of alpha is opposite over adjacent. But maybe we can cancel, make that smaller. Can I cancel a radical 3 with a radical 3? Yes! I could say 1 over radical 2. Look at that. If you make smaller numbers, your calculations will be easier. So what am I going to put in this first parentheses? Oh, good! Radical 2 over 2. Alright, the second set of parentheses. Let's go to our beta picture. Tangent of beta. Okay, make sure you say tangent of some angle. You just can't say tangent of and then say nothing. So the beta picture needs opposites. Opposite is radical 5 over adjacent, which is 2 radical 5. This one simplifies to something really nice. Negative 1/2. Radical 5s can cancel with radical 5s. Oh, don't forget the 1 on top. So this is negative 1/2. Down here, once you do the numerator, these two fractions are right there. Tangent of alpha, once again, radical 2 over 2. Tangent of beta is negative 1/2. And now we really have to see who can do some algebra. So let's see what the numerator is going to be. Do we have common denominators in that numerator? Yes, we do. The common denominator is 2, and the numerator is radical 2 minus 1. Now, what about the bottom? The denominator is 1 minus, let's multiply these together. What's 2 times 2? of 4. And the numerator there, is negative radical 2. So let's change this to plus radical 2. How do you think I should write that 1? Okay, you got to take out your red pen and change the 1 to 4 over 4. Excellent. So now we've got a common denominator of 4. So how does our fraction look now? We have big fraction bar. The denominator's denominator is 4, and this is 4 plus radical 2. Now what I'm going to do up here, take a look, this is a fun technique. I need to have his denominator match. I'm going to multiply this fraction here by 2 over 2. So he gets a denominator of 4. And the numerator would be, make sure you use parentheses there, 2 radical 2 minus 2. Now why am I doing such things? If there is a denominator of 4 on top and a denominator of 4 down there, is it legal to cancel a denominator with a denominator? Yes. And so my problem just got a lot smaller. 2 radical 2 minus 2 over 4 plus radical 2. No, we're not done. We can't leave this radical in the bottom. So what we're going to do is multiply top and bottom by that word you always forget. I'm going to write a note here. Multiply by conjugate of denominator. Denominator. You want to eliminate the radical in the bottom, so he's the conjugate you're going to pick. So let's say 4 minus radical 2. Okay, 4 minus radical 2. And now we have to have good multiplying skills. So where's my fraction bar? Multiply firsts, please. That's 8 radical 2. Outers, that's going to be negative 4. Inners is negative 8. And last, negative times negative is positive 2 radical 2. Alright, the denominator is conjugates. Conjugates makes what class? Difference of squares. So the first is 16. The outers and the inners cancel, and the last is negative 2. Let's clean this up. Can we put those radical 2's together? Absolutely. 10 radical 2 minus 12 is being divided by 14. Now who's going to get divided by 14? The first number or the second number? Oh, both of them. So what I'm going to do here is write this a little differently. I'm going to say 10 radical 2 gets his own denominator, and then 12 is going to get his own denominator, so you guys can simplify and tell me the final answer. 5 radical 2, and that's going to be over 7. Oh, so is this one. That's going to be minus 6 over 7. There you go. Final answer. Make sure tonight you use conjugates, you simplify your radicals, and go all the way to the end. Alright, good luck, pre-calculus. Help each other with the problems in the book, and I will see you tomorrow.